Hello, everyone. Welcome to the 42nd live episode of Ask Abhijit. As you know, today we discuss science, astrophysics, and technology and all that. So let us see who all we have with us. I can see Somnath, Parth, Yash, Dungar Singh Chauhan, Prithvi, Pinky Kumari, Abhijit, Nair, Ojaswa, Ananta, Arpan, Gaurav, Aryan, Devi, Gurav, Parshuram, Gurav, Manu Manoj, Samir Patro, Chiching, Prakash, Kiran, Chandana, Anand, Cherry, Omkar, Dr. Dharmaraj Godke, Neha, Anthony, and so many other people. Gaurav, Neeraj Kumar Singh, Prithviram. Good evening, good day to everybody. Great to be with you. Great to see you all. Thank you for being here. And let's get into it with question number one. So, question number one is by Chiching. Why does the Earth spin? And can we send humans to Venus? So, to understand why the Earth spins, why other planets spin, and why does the solar system spin, etc., we have to understand how the solar system was formed. So, the solar system was formed several billion years ago from an enormous cloud of gas. And this cloud of gas started spinning around its overall center of mass slowly over the millions and billions of years. Started spinning around, and parts of it started coalescing together. These were the seeds of the future planets of the solar system. And at the center of this enormous whirling cloud of gas, you had a big concentration of gas and other material around the center of mass, which became eventually our star, the sun. And once it had sufficient mass, it was able to ignite nuclear fusion within itself. So that is how the solar system formed. It formed out of an enormous spinning cloud of gas, and these local coalescences of mass also were spinning from the very beginning. That's how gravity happens. That's how gravity works. When there is a concentration of mass in any place, it attracts other mass towards itself, and that always goes in the form of a spinning formation, right? So everything was spinning from the very beginning. And that is why the Earth spins, because after everything cooled down and after all these billions of years, that original rotational motion still persists because of the because of the law of inertia and all that. So that is the reason why the Earth spins, the moon spins, the planets revolve around the sun itself spins, the solar system, the entire solar system itself spins, revolves around the sun. And it's why the galaxy itself, our Milky Way galaxy itself, spins. And our sun goes around the center of mass of the galaxy. So this is the reason why the Earth spins. It is the inherent, it's what comes out of the force of gravity. The force of gravity causes such accumulations and concentrations of masses to spin around the center of mass. So that is why this phenomenon is observed. This is why it occurs. Now, can we send humans to Venus? It is possible to send humans to Venus. We have the technological capability, the know-how to do that. We have chemical rockets, which would take a few months to reach Venus. And it is certainly possible. It is not beyond our capability to ensure that a human being or a number of human beings could be transported there safely and even brought back safely. The question is, can humans live on Venus, and can humans even go to the surface of the planet and come back safely? And as of today, that is almost impossible because the conditions on the planet are quite hellish. The atmospheric pressure on the surface of Venus is several hundred times the atmospheric pressure on the Earth. I think it's around 300 times Earth's atmospheric pressure, if I'm not mistaken. And the temperature is also very, very high. It's like in the hundreds of degrees centigrade. So it is so hot and and the pressure is so high that a metal like lead would probably melt on the surface of the planet. So it's not possible to send humans to the surface of Venus as of today. We can certainly send humans in orbit around Venus and most likely bring them back safely. So that is what we can achieve as of today. Venus is, of course, quite close to Earth, the Earth. That's why it is possible to send humans to the planet, have a few orbits done there, and then maybe bring them back. That's what we can achieve as of today. Question 2 by Ajay. Do you think the coronavirus is engineered perfectly so that it can attack people only with certain DNA? Because we don't see the Delta strain in Pakistan or China, but you see it in India or in the US. Well, you are right. Your observation is right. It does seem to be, well, somehow targeted geographically, somehow, because certain strains are seen, they are prevalent in certain countries, in certain geographical regions. For example, if you look at India, you have the Delta strain. If you look at the US, you have the Delta strain. But if you cross over the border to Pakistan, you don't see this. I mean, there's not much of a problem there. If you cross over to Bangladesh, you don't see it. If you cross over to Sri Lanka, you don't see much of an issue. As far as I know, I have not really been tracking the situation in Sri Lanka, but as far as I know, there doesn't seem to be much of an issue there, the way we have it in India. Again, cross over to Burma, cross over to Tibet, there's not much of an issue. So it's clear that it seems to be targeted at the geography of India. Again, the same thing with the United States. In the past, we had certain places like certain nations in Europe, for example, Italy and France and the UK, where you had a very high mortality rate. More than 10% of the infected people were dying in the beginning, in the first quarter, the first half of 2020, if I recall correctly. And the same thing wasn't seen anywhere else. So it is quite apparent, quite obvious that there does seem to be some kind of targeting of certain populations, of certain geographical regions at certain times. And that does give the impression that this is an engineered virus, and whoever is tinkering with the genetic makeup of this virus seems to have found some way of specifically targeting certain ethnicities or certain geographies or uh, certain population groups with a certain kind of DNA. Apparently, it does look like it is that way. So yes, it is. It is, in my opinion, quite likely that this could be a bioengineered virus. And new strains come out from time to time. You have the first wave, then the second wave. Now they are talking about a third wave, right? They're already talking about the third wave, a third wave in autumn of this year. Right now we're in September. Autumn is like October onwards, October, November, those 3 months. So they are talking about a third wave and maybe some new strain. So it's like someone's releasing these various strains of the virus, these new mutated forms of the virus. It looks like that. Of course, we do know that viruses mutate on their own. That is well known. But then if they mutate, they would not target specific geographies or specific populations selectively. So that is what makes it look very curious and very fishy. So I agree, this is very curious, and it doesn't seem to be a natural phenomenon. Ritesh asks, till when can we expect this disgusting COVID time to end? It's been 2 years now, and this terror doesn't end. Well, I had said this a few months ago, I think in Ranveer's show, that this is going to be the decade of the virus. It's not ending anytime soon. New strains, new variants of the virus are coming out every few months. And it's like it's a never ending cycle. We thought that 2020 was the bad year. Well, 2021 is just the same. And even in populations in countries that are almost like where the majority of the people are vaccinated, you're still seeing the virus affecting people. It's as if the vaccine, well, it's pointless, almost like that. So take some countries, for example, Israel. I think more than half the people have been vaccinated by now, maybe 70%, if I recall correctly. I'm not very sure. And yet you have this big problem of people falling ill because of the virus. So it looks like you need one dose, then you need another dose of the vaccine. Now there is talk of certain vaccines having 3 doses. Now there are certain companies that are going to offer pills that you have to ingest twice a day in addition to taking the vaccine. It's like a never ending cycle. So it looks like there'll be more and more strains that come out, and as long as the virus exists, we have to be under lockdown forever, essentially. So it looks like this is going to be the decade of the virus. And so whom does the virus benefit? It does benefit pharmaceutical companies, western pharmaceutical companies who sell vaccines for profit. So one dose is not enough, sell two doses. If two doses, you want to make some more money, sell a third dose as well, make it mandatory, make the politicians ensure that the people have to take three doses, otherwise they are not allowed to go anywhere. you know and politicians the world over, whether it's in North America, whether it's Europe, whether it's Australia, whether it's Asia, politicians the world over are the same kind of people. They love power. They are power hungry people. They are money hungry people. The majority of politicians, I'm not saying all politicians are like that, but the majority of politicians, we know how they are. The entire world over, they love power. As of today, they have gained so much power over the people of the world. They can ask people to stay indoors. They can ask people to wear masks. They can ask people to dance around in circles, and people will have to do it, right? So this is the kind of power they have not had for centuries, for at least a century. And politicians are power hungry. They don't want to give this power up. So now that they have this power to mandate all kinds of nonsense, they will be very loath to give it up. So they may keep on ensuring that something or the other goes wrong, and we have to stay indoors, we have to stay under lockdown, various forms of lockdown, arbitrary lockdowns whenever they want, and just keep on making the world dance to the tunes. That's what most politicians love. And that could be one factor, apart from the pharmaceutical industry factor, that ensures that for many years to come we will be under some form of lockdown. So I don't see this this age of the virus to end anytime soon. I don't see it ending anytime soon. I think this entire decade is going to be like that, and perhaps the world has changed forever. We will never have the freedoms, perhaps, that we had until 2020. Those freedoms may be a thing of the past. Vaccine passports may become mandatory. You will not be allowed to go to a cinema hall unless you're vaccinated, unless you had your 2 or 3 doses of the vaccine and you've paid for that. You may not be allowed to go to restaurants. You may not be allowed to get on a plane. You may not be allowed. You may not get a visa for another country unless you demonstrate that you have taken the vaccine. And maybe the Indian vaccine won't be allowed. You have to take some other vaccine which they like, which brings them money. So that's the kind of nonsensical era we have entered. Everything is commercialized, everything is monetized, and so that's where we are today. I don't see this ending anytime soon. This may be the entire decade of the vaccine, unfortunately. Avinash says, if humans evolved from monkeys, why do monkeys still exist? Well, I think it's a good question. It's a good question. It's a logical question. It's a good question. So let's take a broader look at the world. Tigers evolved from cats, from ancient cats. But other cats do exist. Lions evolved from cats, ancient cats. But other cats do exist. We have cheetahs, we have leopards, we have bobcats, we have lynxes, we have pumas, we have the clouded leopard, the spotted leopard, the Amur leopard, we have the house cat, we have various species of wild cats, right? So we have so many species of cats. And yet the most evolved, the strongest ones are the lions and the tigers. It's because there have been many species of cats over the past millions of years. Let's take a look at the dog. The dog, the domesticated dog, is a subspecies of the wolf. So these dogs and wolves, they are the same species essentially. They evolved from ancient canine species. But you do have foxes, you do have jackals, you do also have bears who are closely related to dogs. You also have seals, and you also have the baleen whales and the porpoises and dolphins, who are all part of the broader family. So there have been several species of the same family of animals, out of which dogs have evolved, right? Now, when it comes to dolphins, we have dolphins, the regular common dolphin, bottle-nosed dolphin, but we also have the orcas, the killer whales, which are the largest species of dolphin. We also have other species of dolphin. We have the Gangetic dolphin, we have the Iravathi dolphin, and we have several species of dolphin. So the dolphin, the regular common dolphin, is supposed to be the second most intelligent animal that we know of after us. So they evolved from ancient dolphins. So why are there so many other species of dolphins? It's because there have always been many species of dolphins, and one of these species happens to be the most evolved today. Similarly, in the past, there have been several species of monkeys and apes, and the most intelligent one of those today is us. We are the most intelligent monkey or ape today. It doesn't mean that there should be no other monkeys or apes, right? So that's how it is. It's always been like that. There has been this parallel evolution, many parts of evolution of closely related species of animals, right? Families of animals. I think a family has a number of species within it, and so on and so forth. So that's how it is. That's how evolution works. It happens in parallel. It's not linear. Of course, it is linear if we trace back our own ancestry, but then if we go back several million years, it converges with the lineages of other species as well. So that's how it goes. Aniket says, what if we use 100% of our brain? Some science fiction movies claim that we will be able to use our psychic powers and time travel and control everything just like being a god. Please answer. See, we have to understand that science fiction is mostly entertainment. It's about entertaining the masses. It's about entertaining the audience. Not all science fiction is hard science. There is a category of science fiction called hard science fiction, and then there is all the other science fiction. And in bookstores, science fiction and fantasy is always together. So fantasy is not even science, but but many people believe that fantasy and science fiction are the same thing. So the thing is this, that we most likely do use 100% of our brain. Our brain has it's a large thing. It's a large organ. It's the most energy intensive, energy hungry organ in the body, as far as I know. Yeah. Now, we don't understand how the brain works. We know very little about the brain. We know maybe 2 or 3% of how the brain actually works. We know what is the internal structure of the brain because we have been dissecting brains for the past few hundred years. We know how it is inside. We know what is the neural structure to some extent, right? Ganglions and dendrites and clusters of neurons. And it's most likely the connections between these neurons that produce memories. Then the question arises of consciousness. What is consciousness, and so on? We know that there is an internal brain, the reptilian brain, then there is an exterior brain, and so on and so forth. And all of these various regions and parts of the brain have their own functionality. They have their own use, they have their own function, and they do fulfill the function. See, nature is parsimonious. Evolution ensures that there is nothing extraneous in an organ which is not needed, because anything that's extraneous is a burden to an organism, and it will ensure that it gets weeded out in the survival of the fittest. So everything is well designed. It has evolved over millions of years, and every part of our brain is actually functional. It has some use, it has some function, it has a purpose that it does serve. We don't understand what these purposes are. We don't understand what the various parts of the brain do. It doesn't mean that we don't use 100% of the brain. So that is something we have to understand. Science fiction is mostly entertainment. And some people talk about hacking the brain and trying to overclock the brain, inject data into the brain. See, we don't understand how the brain works. And if we start fiddling with the core functionality of the brain, it's going to cause problems in whichever person's brain you do these experiments. It can even cause someone to go insane. Who knows what's going to happen, right? We don't know why we sleep. What is the use of sleep? I mean, almost every organism on the planet has some form of sleep, especially multicellular organisms and organisms that have significant brains. So, so sleep does seem to have some function, but we don't know what it is. Now, one of the ways people talk about of hacking the brain or using more of the brain is by trying to eliminate the need for sleep. Well, it has been observed that when an organism is deprived of sleep over a period of 7, 8, 10 days, it inevitably leads to death. Right? The animal or whoever it is dies if this is done, and therefore you are trying to do something that is highly unnatural. So my point is that we don't really understand how the brain works. It is a very popular myth and misconception because of science fiction movies and fantasy movies that we only use maybe 1% or 2% of the brain. If we take some super drug, then we'll start to use everything else, and it may give us superhuman powers. That is a very dangerous myth. It should not be taken seriously. It's good for science fiction and fantasy movies, but that's not the real world. So that's the answer to this question. Akash says, why do stars which are situated far from the center of the galaxy revolve faster or at least as fast as a star which is closer to the center? Because this doesn't work in the solar system. Mercury revolves around the sun faster than Pluto, but this doesn't happen at the galactic level. Why is that? This is a very good question. So here's what it is. See, the solar system, if you look at the solar system, if you look at the mass composition of the solar system, more than 99.8% of the mass of the entire solar system is just the sun. So the sun itself, all by itself, makes up more than 99.8% of the mass of the entire solar system. Now, when you have a planet going around, let's say the sun, in orbit, so it's orbital motion, then what happens is that the centripetal force and the centripetal acceleration and gravitational acceleration have to balance out to maintain the planet in orbit. It also works when you have a satellite in orbit around the Earth. And it all depends, the speed of the orbit, the orbital velocity depends on three factors. But if the main object is very massive, then you can just take two factors. One is the mass of the object that is being revolved around, and secondly, the distance of your planet from the sun, let's say. Okay, so in the case of the solar system, as we go closer to the sun, orbital speed it rises. The orbital velocity it gets higher, faster and faster. That's why Mercury, Venus, Earth, Mars have high orbital velocities, whereas Uranus, Neptune, Pluto, etc. have very low orbital velocities, because you have the same mass that they are revolving around. Now, when it comes to the galaxy, you have a supermassive black hole at the center of the galaxy. But as you go further and further away from the center of the galaxy, the mass of the galaxy increases, right? Because the galaxy is a big diffuse object. In the case of the solar system, most of the mass, more than 99.8% of the mass, is right at the center. So no matter how far or close you go, you're always orbiting the same amount of mass. But in the case of a galaxy, as we go further and further away from the center, you're orbiting a more and more massive thing. Because if you look at the radius of your orbit, there is more mass as you go outwards that you are orbiting. And that is the reason why, because the mass increases, this the speed of the orbit also increases. And this is what we see in the galactic rotation curves. Let me share that image. So this is a galactic rotation curve. So you can see that as the distance from the center of the galaxy, see over here you can see the center of the galaxy. If you can see my mouse pointer, over here is the center of the galaxy. As you go further and further away from the center of the galaxy, the speed of rotation of stars increases, whereas it is supposed to decrease, or if all the mass was in just one place at the center, it is supposed to decrease. And that this phenomenon is observed because of the presence of dark matter. The galaxy has a very sizable dark matter halo. I think the diameter of the dark matter halo is about 2 million light years, which is enormous. So as you go further from the center of the galaxy, there is more and more mass that you are revolving around. And that is why the speed increases as you go further instead of decreasing if all the mass was just concentrated at the center. It's a reasonably technical thing to understand, but it's so that's how it goes. If you understand what orbits are made up of and what is the physics behind orbits, then you will figure this out. Aniket says, what's your opinion about Elon Musk? Do you think he is some kind of revolutionizer or something? In my opinion, he is very overrated. He is a great businessman. That's it. He isn't a scientist as he portrays himself. Tesla wasn't founded by him, neither was PayPal. So, what actually is his contribution in the field of science and technology? So, listen, I haven't really studied the history of Tesla or PayPal, so I don't know who founded it. That doesn't really matter. So as far as I know, Elon Musk has degrees in physics. I think bachelor or master's degrees. I think at least bachelor's degrees. And if I recall correctly, he did get admission to a PhD program in one of the major US universities. I think it was Cornell, if I'm not mistaken. He got into the PhD program in physics in one of the major US universities, and he chose to drop out of it. So he was clearly good enough to get admission as a PhD candidate in a top US university. Now, I am sure he doesn't have a PhD degree. So what is the definition of a scientist? Are you a scientist if you have a degree? Like if you have a master's degree in physics, does it make you a scientist? Or do you need to have a degree, like a PhD degree in physics to be a scientist? Is the degree all that matters to be a scientist? There are thousands, tens of thousands, maybe millions of PhD holders in this country, in India, who are not scientists. They haven't produced a single original scientific discovery or anything at all. So having a degree of some kind doesn't make you a scientist. I know Elon Musk doesn't have a PhD. Does it mean that he is not a scientist? And many of these PhD degree holders who are officially scientists in the eyes of the world, what do they do? What do they contribute to society? They write research papers which are published in obscure journals that nobody reads. The only people who read these papers are other scientists. That's a very small community. And more than 99% of these papers will have no real impact on the world. They will not make any great change in the world. It's like, there's this saying in science, in academia, publish or perish. So if you want to keep progressing or in riding and climbing the academic ladder, you have to keep publishing research papers every year, a number of papers every year, 4 5 at least per year, at least 3, I would say. And that ensures that you keep climbing the academic ladder. You get promotions and you eventually get tenure. But what difference does it make to the world? What good does it do to the world? These people are officially scientists in the eyes of the world. They have a position, they have a degree. But if you look at the history of the past 40 years, there's not been one single new discovery in physics that throws new light upon the universe as we understand, as we see it. Physics has not progressed in the past 40 years. So what is the point of having these degrees and having these academicians and all that? What good are they doing to the world? That's my question. I'm not saying Elon Musk is good or something. I am saying, what is the meaning? What is the definition of a scientist? What's the definition of an intellectual? An intellectual is somebody who produces new ideas. It's not somebody who reads hundreds of books. I have all these books behind me. Does it mean I'm an intellectual? I am not an intellectual if I read 500 books or 1,000 books. There are people who say, I read 50 books a year, so I'm an intellectual. An intellectual is a person who produces genuine new ideas that are actually useful to society, that actually take society forwards. There are many people who produce these garbage ideas, who produce research papers, who publish books that make no difference in the world. It's just the regurgitation and rehashing of old ideas. So, publishing a book doesn't make you a scientist or an intellectual. Publishing research papers that are worthless doesn't make you a scientist or an intellectual. Reading 5,000 books doesn't make you an intellectual or a scientist. A scientist is somebody who produces genuine new ideas and brings the world forward. Now, what does Elon Musk do? He is definitely a businessman. He wanted to be a physicist. He went for a PhD in physics, and then he abandoned it because most likely he did not like the academic environment. And he sought to succeed in this adoptive country of his, the United States. And as a businessman, to succeed in the US, you have to, well, play by certain rules. And he found a way of succeeding at that. He is definitely a great businessman. He is not a scientist, I agree, because he is not doing any research. He is uh, trying to find ways of sending humans to Mars. He is, of course, putting all these satellite constellations in space. Iridium, I think. Yeah. So yeah, he is doing all that. He does not fit my definition of a scientist, but he's clearly a visionary. Of course, all his work is going to benefit him. It's going to enrich him. So if you think that is bad, well, then that's not a very good thing. I would say that any progress in business, any progress in science should benefit the whole of humanity. But the American capitalistic system is not like that. Everything is monetized. Even vaccines are monetized. Any scientific invention is used to make money for a very small number of people, and that's just the way the system is. So he wanted to succeed in that country because there was nothing for him in South Africa. There was no entrepreneurial environment there. So he chose to come to the US. He chose to try and succeed there. He has succeeded. So that is his contribution to the world. He will he will possibly succeed in sending humans to Mars, I suppose, in the next 10, 20 years. Whom will it benefit? It will benefit a small number of people. It's not going to be used for the benefit of humanity. It's going to be used, well, to enrich him, his company, his shareholders, stakeholders, and so on. That's just how the game is played. So that's about him. I don't see him as a bad person. I don't see him as somebody who is evil. I think he's better in some ways than many other business people. He is not a scientist. He has chosen not to be a scientist. He was clearly good enough to be one, at least by the academic standards. He would have gotten himself a PhD, and he would have maybe published a bunch of research papers, but that's not what makes a scientist. So all in all, that's about Elon Musk. I don't see him as an evil person. I see the system. Well, I am saying this capitalistic system is evil. It does not mean I'm a Marxist or a socialist. Marxism and socialism is equally, if not more evil than capitalism. But that's just the way the world is. I have spoken about geopolitics in the past. It's all about conquering the world, and it's all about pursuing your personal interests selfishly. Well, so is the capitalistic system. That's also the way it is. So he has found a way to succeed in that, and it's good for him. Okay, Jagyan Jatin says, do you think humans will survive a mass extinction, or will we go on like this forever? So is humanity in a position to survive a mass extinction, or will humanity last forever? Well, you know what? Nothing lasts forever. We have had many species of human beings in the past that have disappeared. We are a relatively new species of human being. We have been around for 250,000 years in the anatomically modern form, Homo sapiens. Now, are we in a position that we can survive a mass extinction? So what's a mass extinction? It's a catastrophic event of some kind in which a majority of the living beings and species on the planet go extinct. So that could be something like an asteroid strike or a comet strike, or like what happened about 65 million years ago in the Chicxulub impact event, which what killed off the majority of the dinosaurs. Some dinosaurs did survive, and our ancestors, who were very small at the time, they also did survive that. So they did survive the mass extinction that killed off the majority of the known avian dinosaurs, right? So that is one mass extinction our ancestors survived. Now, are we in a position to survive another such mass extinction? What if a comet were to impact the planet? I don't see humanity surviving that. We can try and nudge the comet out of its orbit that will coincide with the Earth's orbit. That we can do if we can see it coming with sufficient time in hand. We may be able to deflect an asteroid and nudge it out of the way if it is coming towards the Earth. But if it is too late, and if it does impact the Earth, then there's no way humanity can survive. We will go the way of the dinosaurs. Now, there are other ways of having a mass extinction. For example, right now we are destroying the oceans. We are polluting the oceans. We are choking the oceans with plastic, and we are dumping all kinds of chemicals and other things into the ocean. In the past, there have been mass extinction events that saw uh, anoxic conditions in the oceans. So the oceans have these organisms called phytoplankton. These are unicellular or multicellular microorganisms that have chlorophyll, that undergo photosynthesis, and at least half of the entire planet's oxygen is produced by these phytoplankton organisms that live in the world's oceans. Now, if we were to engineer, because of our stupidity, an anoxic event in the oceans, which means that the oceans they get starved of oxygen, then all of this phytoplankton will die out, and many other species will die out. And if the oceans die out, we will lose one of the we will lose the major source of oxygen on the planet, and that could trigger off a catastrophic chain of events that could wipe out the majority of the species, at least the terrestrial species on the planet, including humanity, because it would kill out many of the smaller animals and plants, and that would lead to the starvation eventually of humanity. So there are many mechanisms by which a mass extinction event can take place, and I am afraid that we are not currently in a position that we can survive such a thing. We don't have another planet that we can go to, because none of the planets in our solar system have anything like the conditions we would need to survive there, and we don't have the means to send a significant percentage of humanity to any of the planets, whether it's the moon, whether it's Mars, whether it's Venus, right? So this is the only home we have, the Earth, as of today. And if something were to go wrong here, I don't see humanity surviving that. So unfortunately, we are currently not in a position to survive a mass extinction event. If that were to happen, we are in a position to ensure a mass extinction event does not happen. So we need to get our act together. We need to ensure that we stop polluting and destroying the oceans. We need to ensure we stop deforesting the terrestrial regions of our planet. We need to stop polluting the atmosphere. If we can do that, if we can stop all this animal agriculture, if we can stop people eating beef, then a great deal, we can change a great deal in the world, and maybe ensure that our future generations will have a better world to live on, and we will ensure that a mass extinction won't happen. But it needs to start happening now or very soon. But otherwise, we may not be able to survive a mass extinction event. Srishti says, is there any cosmology branch in India? How can a person in India become a cosmologist? Okay, so cosmology is a branch of physics that deals with the chronology and the history of the universe, and the physics of the universe at very large scales, the large scale structure of the universe, and it combines astronomy and the laws of physics, and also sometimes chemistry, etc., to understand how the universe evolved over time and what is going to be the ultimate fate of the universe in the very distant future. So that's what cosmology is about. So how do you become a cosmologist in India or anywhere else? First of all, So to become a cosmologist, you need to have a solid understanding of theoretical physics. You need an understanding of general relativity, of quantum mechanics, of electromagnetism, of solid state physics, and various other allied and associated branches of physics. You need to have a very good understanding of all these various branches of physics. So, and I'm not sure if any universities in India offer courses in cosmology, but there are certain some. So what you would need is you would need at least a master's degree in physics in with your specialization in either quantum physics or nuclear physics or general relativity or quantum physics or electromagnetism or one of these closely allied fields in theoretical physics or maybe solid state physics, etc. You would need a master's degree in that, maybe a PhD in that, and then maybe you would get uh, employment in one of the institutes, one of the few institutes in this country, in India, which do have some research in cosmology. So I think the Physical Research Laboratory in Ahmedabad has some research in cosmology maybe happening there. TIFR Mumbai, perhaps. Then there is a National Center for Radio Astrophysics. I think it's a branch of TIFR in Pune, which does do some astronomical, astrophysical, cosmological research to some extent. You have the Raman Research Institute in Bangalore, the Indian Institute of Science in Bangalore. You have IUCA, Inter University Consortium or Center for Astronomy and Astrophysics, again in Pune. And you have the Indian Institute of Space Science. I think it is in Trivandrum. So these are some of the Indian institutes, research institutes that do some research in cosmology. So that is the path you would have to take. You would need a master's degree and possibly a PhD in one of these specializations. And then you can apply for a job in one of these institutes or institutions. And that's how you would become a cosmologist. If you do want to make a real difference and do genuine research in cosmology, you will have to go abroad. Now, you know very well what I feel about this. I would very much want to see world class research being done in India. As of today, it is not the case. There is no real cutting edge world class science research being done in India anywhere. So, if you really want to become a genuine world class cosmologist and do some real difference in research in cosmology, you would need to go to another country, maybe in Europe, maybe in North America, etc. And maybe in the future, when India does get its act together and start doing genuine research, then maybe you can come back and contribute to the country. But that is, in short, how you would become a cosmologist. That is the path you would follow towards becoming a cosmologist in India. Shreyas says, what is a Matrioshka brain? So, if you know what a Matrioshka doll is, it is this nested doll that you have that is so uh, typical of Russia. You have a doll. If you open the doll, there's another doll inside. You open that doll, there's another third doll inside, and you have dolls all the way in. So, it's a nested series of dolls. That's called the Matryoshka doll. So, a Matryoshka brain is a hypothetical science fiction structure that is built on a stellar scale. So it's essentially a Dyson sphere. A Dyson sphere is a mega structure that envelopes an entire star, and it's able to capture the entire energy output of a star. So that's a Dyson sphere. So a Matryoshka brain is a computer in the form of a Dyson sphere. So you have a star that is completely enveloped by this mega structure, by this Dyson sphere, and the energy output of the star is utilized to do computational activity. So it is a computer that is larger than a star. Now, as you know, any computer, a laptop or a computer of any kind, it does calculations. It does computations of all kinds. It does need a power source, and it gives off heat, waste heat, as a result of all the computational activities it does. So, in the case of a Matryoshka brain, the Dyson sphere that envelops a star would use the star's heat and light output as the energy source. It would do computations and it would give off waste heat. It would output that out. Now, a Matrioshka brain is one Dyson sphere, and there's another Dyson sphere around it, which takes all this waste heat and uses that as the energy source for more computation. It gives off more waste heat, and there's a third Dyson sphere around it that takes in this uh, emitted heat as the energy source. And there's a whole concentric series of Dyson spheres that are actually enormous computers that all use this output, this heat that is output for computational activity. So it is a series of nested Dyson spheres that act as computers. And that is the concept of a Matryoshka brain. So this is a hypothetical science fiction scenario. We don't know of any civilization anywhere that is capable of doing this. We have not thus far encountered any non-human alien civilizations, but it is clear that if a civilization were to be sufficiently advanced, it would be able to engineer this sort of a structure. It is certainly possible. It is not impossible. The laws of physics don't uh, preclude this sort of a machine from being constructed, but it is well beyond the capability of the human species. But it is certainly possible, theoretically, hypothetically. Dominic says, is it possible to make a spacecraft that uses the plentiful hydrogen available in outer space? So that's a concept that has been again discussed in science fiction. It's called a Bussard ramjet. So in a Bussard ramjet, you would have a spacecraft with a fusion engine. It fuses hydrogen, and this fusion reaction impels it forward. And in front of the spacecraft, there is this enormous ram scoop, which is a scoop that's made up of enormous magnetic fields that go out into space for thousands of kilometers, maybe millions of kilometers. Now, we know that the interstellar medium is full of this very diffuse hydrogen gas. It's extremely diffuse, and this interstellar medium is a better vacuum, a more perfect vacuum than anything we can have on the planet Earth. And yet it does have hydrogen atoms. It has a very low density of hydrogen atoms and perhaps even molecules in some places. So a Bussard ramjet would exploit this property of the interstellar space. So the spacecraft would be propelled by a fusion reaction, and it would have this enormous ram scoop in front of it, magnetic fields that extend for thousands or millions of kilometers. And these magnetic fields suck in all this diffuse hydrogen gas, and they bring it all into the input of the fusion engine of the ramjet, and that's what serves as the fuel for this enormous ramjet engine. So yes, it is definitely possible, if you have the technological means to create such a machine, to use the interstellar hydrogen for fuel in a spacecraft. It is definitely possible. But of course, once again, we don't have anything close to that sort of technological ability as of today. Maybe 1,000 years in the future, if we last that long, then maybe we may be able to build such a spacecraft. Akash says, does the dark matter halo, if it exists, envelop the galaxies and also permeate them? Also, are we inside this dark matter halo? So we know that dark matter halos do exist. We have observed them. We just discussed the galactic rotation curves, which is one of the signature, one of the phenomena that tell us that these dark matter halos do exist. So a galactic dark matter halo is typically spherical in shape. We know that galaxies are pancake shaped, most of them, especially spiral galaxies like the Milky Way and the Andromeda galaxy. But the dark matter halo, which we can't see, but whose gravitational effects we do observe, these halos are spherical in shape. And for the Milky Way, the dark matter halo has a diameter of about 2 million, 2 million light years. It's a spherical halo, and the dark matter is not only found in the exterior parts of the galaxy, it is everywhere. It is all around us. It is everywhere. We are currently inside the dark matter halo. It is in this room where I am right now. Wherever you are sitting and watching this, it is in your room as well. It is passing right through you, but you don't feel it. So that is what dark matter is. It is an unknown particle or substance which interacts only gravitationally, and the gravitational interaction is so incredibly weak that we can't perceive it, especially when it comes to very small particles. Yeah. So that is what it is. We are in it. We are bathed in dark matter particles, but we have no idea what they are. So it is right here at this very moment. I am sitting in an entire ocean of dark matter particles. The sun is inside an ocean of dark matter particles. Our Milky Way, our solar system, it's passing through a wind of dark matter. And that's what it is. Dungar Singh Chauhan says, what is the shape of a black hole? Can we see the back side of a black hole? So when it comes to black holes, when we talk about the shape of a black hole, we are talking about the shape of the event horizon of a black hole, which is the boundary of no return. So once a light particle, a photon, crosses the event horizon, it never comes back. It is not capable of coming back. That is just the way it is. So the shape of a black hole is the shape of the event horizon of the black hole. So for a non-rotating black hole, which is also called a Schwarzschild black hole, the shape is perfectly spherical. It's a perfect sphere in the case of a Schwarzschild non-rotating black hole. But for rotating black holes, the shape of the event horizon is oblate. It's like a squashed sphere. So on the poles of the sphere, the poles are the essentially the axis around which the black hole is rotating. So around the poles, the black hole is slightly squashed, and around the equatorial region of the black hole, it is slightly elongated. So it's like a squashed sphere in the case of a rotating black hole. Now, can we see the back side of a black hole? Well, a black hole has there's nothing to see in it. It's completely dark. It's completely, you could say, transparent. No light ever comes out of it. So you cannot really see the back side of a black hole or any side of it. But what you can see is light that is behind the black hole. So recently this phenomenon was observed, that light actually went all the way around the black hole, and we were able to see it again. So an object which is behind the black hole, we may be able to see it because of this phenomenon in which light, the space-time itself is warped and bent, and light curves because of this phenomenon, right? It's called lensing, gravitational lensing. So let's say I am sitting here, I have a black hole in front of me, and there is a star precisely behind behind the black hole. So which means that the black hole is exactly between me and the star. Then I will be able to observe the light of the star which comes behind the black hole. It just curves around the black hole. So that is what we do indeed see, but we cannot see anything about the black hole itself because it is completely and perfectly, well, almost perfectly dark. There is the phenomenon of Hawking radiation, which is a completely different thing. So we don't get to see any features of the black hole or anything, but we do see a flux of radiation that comes out of it, which is a separate phenomenon. Pinkline Cabs says, will automation destroy or save humanity? Well, automation is a bunch of technologies: robotics, artificial intelligence, machine learning. So you have software automation, you have algorithmic automation, you have actual physical automation done by assembly line robots, other kinds of robots, and so on and so forth, right? So automation is a tool, and tools can be used in a variety of ways. You can use a tool for something good, you can use a tool for something bad. It all depends on who is the person or the organization or the entity that holds the tool in their hand, right? So today, if you look at the world, who runs the world? It is the Western countries that essentially run the world. It is these big capitalistic corporations who run the world. And the entire objective of the global system today is to make money. It's all about that. It's the system that has been placed since in place since the days of the colonization of the world by the European countries. It's a system that has been placed that has been in place since the days of the East India Company. It's all about amassing money, and the better tools you have, the better you are at amassing money. So today, artificial intelligence, machine learning, robotics, it is all being developed by various corporations and various powerful governments who have all the money, and they are using it to amass more resources and more power and more influence for themselves. So as of today, automation is going to make a small number of countries and a small number of individuals and a small number of corporations incredibly, insanely rich. And it's going to happen at the expense of the rest of the world. And that's why there is this arms race of a sort going on, technological race, in which technology is the new arms, right? So automation is one part of that. So it's all about how you use it. And today, the people who are using, who are developing these automation tools, they are doing it for the purpose of enriching and empowering themselves, not for the benefit of humanity. Today, we already have enough money and enough resources to end world hunger once and for all. We have enough money, enough resources to ensure that everybody has good standards of living all across the world. And yet, you have so much disparity, so much inequality. It's because all of the wealth has been stolen and amassed by the Western world. And now they are using various other tools, such as automation and other technologies, to enrich themselves even more. This is a new kind of colonization. So, as we stand today, automation is going to, well, it's not going to save humanity. It's going to make the rich richer and the poor poorer. It's going to make the powerful even more powerful, and it's going to disempower everybody else. So that is the direction in which we are going, and that's why I keep saying India needs to rise, and it needs to rise on its own terms. Today, India is a second rate knockoff of the West. That's what India aspires to be. That's what India's leaders aspire India to look like in the future. An English speaking, second rate knockoff, a cut price copy of the Western model, of the Western world. India does not. India should not go in that direction. India needs to rise again as a civilization on the basis of its own cultural and civilizational values. Only then will we have an alternative model to the model that we have today, which is the model that even the Chinese are copying. So that's what needs to happen. Avinash says, what is the meaning of baryonic matter? That's a good question. So, what is a baryon? So, see, baryons are subatomic particles that are made up of odd number of quarks. So you have six quarks. You have the up quark, the down quark, the charm quark, the strange quark, the top quark, and the bottom quark. And these quarks have fractional charges. The up quark, the charm quark, and the top quark have plus two-thirds elementary charge. And the down quark, the strange quark, and the bottom quark have minus one-third elementary charge. These are the most fundamental particles that we know of, these six quarks. And baryons are particles that are made up of an odd number of quarks, at least three quarks. So, for example, you have the proton, which has UUD, one up quark, another up quark, and a down quark in a bound state. So the proton is a bound state of two up quarks and one down quark. It has a positive one charge. The neutron is a bound state of one up quark and two down quarks. So these are triplets of quarks, and these are what are known as baryons, right? You also have exotic baryons, pentaquarks, which have been observed. So these are bound states of five quarks. So as long as you have a bound state of three or more quarks, and it is an odd number of quarks, that is what is known as a baryon. You also have mesons. Mesons are bosons. They are bound states of even number of quarks. So that's how it goes. So baryonic matter is essentially matter that's made up of protons and neutrons. So most of the matter that we see around us, that we experience in the world, is baryonic matter. You also have leptons, that are electrons and neutrinos, and various other kinds of particles in this subatomic particle zoo. But that's what baryonic matter is. It is matter that follows Fermi-Dirac statistics. These are fermions, as opposed to bosons, which obey Bose-Einstein statistics. So that, in a nutshell, in very brief, is what baryonic matter is. Dungar Singh Chauhan says, is there anything non-physical in existence? If yes, then what would be its definition? Can we perceive it through our logic and senses? See, this is a question about that transcends the physical world and goes into the philosophical world. So what can we perceive through our senses? We can perceive physical things through our senses. Our senses are all predicated on mostly electromagnetism, which is how we perceive light and color and all that. We perceive sound through the vibrations of the air, acoustic vibrations of air, and we perceive things like shape and hardness and all that because of quantum mechanics, because of the laws of quantum mechanics. So these are the reasons why we perceive what we perceive, and this is all physical. Now, we do know that we are conscious. We do perceive something called consciousness, but we don't know how to define it. And we don't know if it is an emergent phenomenon or it is something else entirely. We don't have the foggiest idea of what that is. So is consciousness physical or non-physical? Is it something we imagine, or does it really exist? These questions are still unanswered. So that is the only non-physical thing that if it is non-physical, that we may be able to perceive. Maybe it itself is something that emerges out of ordered complexity, perhaps. We don't know. This is all speculation. Now, what is the definition of something that is non-physical? Something that is non-physical is something that is not observable. It is either an object that is non-observable or a phenomenon that is non-observable. For example, the soul. The soul is something that has never been observed. You can't measure it. You can't quantify it. You don't know its shape or its size, its color, its weight, or anything like that. It is something that people believe in, but it has never been observed scientifically, unambiguously, or even ambiguously. It's never been observed. So that is something that is non-physical. Does it exist? Well, as a scientist, I have never seen any evidence of it existing. Do I believe in it? Well, that's entirely personal to me. Many scientists may believe in the existence of a soul or of a god or gods or whatever. But in the physical world, we cannot observe, measure, quantify these non-physical things. So do these things exist? Do non-physical entities, objects, phenomena exist? We cannot observe them, and therefore we cannot say for sure whether they exist or not. From a purely scientific perspective, what is non-observable, what is non-measurable, what is non-quantifiable does not exist. And science is limited to the observable universe. It doesn't mean that certain things may not exist, because our understanding of science is very, very rudimentary. Our instruments, our senses are very rudimentary, very primitive. And therefore, if our scientific instruments, if our senses were to progress further, then we may be able to to observe certain things that we currently consider to be non-physical. But as of today, none of the non-physical things is observable, such as the soul or God or gods or spirits or whatever you call it. We cannot observe it, and therefore we cannot say that it exists. We cannot claim without evidence that it exists. We cannot perceive it through our senses or through logic, but it doesn't mean it doesn't exist. Okay, so that's my position on that. Okay, Mayuri says, while the dinosaurs were here for 270 million years, they did not care about the sun or the stars. We, on the other hand, in our short 7 million years, have reached the moon and Mars. So, which of the following statements is right? A, we are nothing but a tiny speck of dust in the vast universe. And B, the universe has meaning because there is something us to observe it. Well, that's again a philosophical question. Um, the dinosaurs were here for some few 100 million years. Well, we don't know whether they cared or not about the sun or the stars. We don't know. Maybe there were certain reasonably intelligent dinosaurs who liked to look at the stars and look at the sun, and they were aware or conscious of the existence of the sun and the stars or the moon. We don't know. We cannot assume that there were no reasonably intelligent dinosaurs. I'm sure there were certain dinosaurs that were as intelligent as our dogs or the dolphins or elephants. It's entirely possible. So maybe some of them did care, did observe, and did perceive these things. Now, we as humans have existed for about maybe 2 million years, 3 million years. Homo sapiens, as our species, has existed for about 250,000 years. Now, we have indeed reached the moon, we have sent spacecraft to Mars and to other places. So, which of these following statements is we are indeed a very small speck of dust in the vast universe? We know that the observable universe has a radius or diameter, is it 90 billion light years? I think it's the diameter. So we are clearly insignificant in comparison with the size of the observable universe. The actual universe may even dwarf what we see of the universe. So if you look at the size of the solar system, if you look at the size of the Earth, it's clearly an insignificant, tiny speck of dust. There is no question about it. It is indeed true. There may be many more advanced species of beings out there in the universe that we have not yet observed. So we are clearly insignificant. We are clearly very small, insignificant, tiny, all that. Question B is, does the universe have meaning because there is something us to observe it? Well, that again is about the observer effect. Something doesn't exist unless it is observed. Einstein once said that, does it mean that the moon doesn't exist if I don't look at it? So again, this is a philosophical question. We don't really know the answer. I remember when I was a little kid, I used to wonder, if I'm not looking at something, does it really exist? And then I would quickly turn around and look, and yeah, it's there. But does it exist when I'm not looking? That was the question that I had when I was a kid. And it turns out it's one of the fundamental questions. I mean, does the universe exist if we are not observing it? There are certain parts of the universe that may never have been observed by humans. So does it mean that for all intents and purposes, those parts of the universe don't exist? These are some very fundamental questions that arise out of our study of the ultra microscopic world, quantum mechanics. So maybe there's a possibility that reality is meaningful only when something is observing it. And what is that something? Is it an intelligent observer? Is it a consciousness? So these questions, we don't really have an answer to them as of today. These are the deep mysteries that we are currently wrestling with in our study of this extremely mysterious field of physics, quantum field theory, quantum mechanics, especially the interpretation of quantum mechanics, because it does throw up extremely strange and rather uncomfortable paradoxes at us. So I would say that we are to answer the two questions in short, we are indeed nothing but a tiny speck of dust in the whole universe. And the second question, we don't really know. Maybe the universe does exist without any observer observing it, or maybe it does take an observer to observe the universe to bring it into existence, which then makes us ask this big question that a wave function doesn't collapse into reality unless it is observed by an external observer. Now, our universe itself has one wave function, and we know the universe exists. So, which external observer is observing the universe? That's the question, right? So, yeah, it throws up all kinds of mysteries and paradoxes and things that kind of transcend science and physics. And we currently don't have answers to this. Akash says there were so many different types of human species. Why did only Homo sapiens survive? That's a good question. So, see, Homo sapiens as a species is a very recent species. It's about 250,000 years old, a quarter of a million years old. The most successful species of human that we know of is Homo erectus. So the oldest fossilized specimens of Homo erectus are found in Africa. That's about 2 million years old. We know that there is evidence that Homo erectus made its way into Asia about 1.7 million years before today. And the last known existence of Homo erectus is about 100,000 years before today in Indonesia. So it seems to have died out as a species only 1 lakh years before today. So Homo erectus is the most successful human species of all time. It lasted almost 2 million years, almost. And compared to that, we are very recent, just a quarter of a million years old, right? So there have been many types of human species. Now, did only Homo sapiens survive is the question. You know that there have been other subspecies of humans like the Neanderthals that were alive until about 20, 30,000 years ago. We know that the Denisovans also existed, a different subspecies of humans. We had the Homo florensis from Indonesia. We had Homo erectus and so on. We also know that we carry about 4% Neanderthal DNA, which means that we have Neanderthal ancestors. It's like having one great grandparent or something like that. One great great grandparent who was a Neanderthal, or maybe one great grandparent. The math is very simple. So we do have Neanderthal DNA. We have had Neanderthal ancestors, which means that they haven't really died out entirely. Their descendants are still alive. There is us. So it's clear that sapiens is not a pure species. It is a mixed species. We have Neanderthal DNA. Some of us also have Denisovan DNA. So again, it means that the Denisovans did not die out entirely. Their descendants are still alive. And that is us. And there is another ghost ghost population whose DNA exists within us. And that population, that species or subspecies has not been identified. And that could very well be the great Homo erectus. So what I mean to say is that there is no such thing as a pure species. There is no such thing as a pure, no pure species, right? So it is incorrect to say that the Neanderthals died out entirely. It is incorrect to say that Denisovans died out entirely, or maybe even though the Homo erectus also still survives in some way, in some form, through us. So we are the sum total of a great number of different species that interbred together. There may be many other unknown populations whose DNA we are still carrying, right? So we are the only ones that have survived till now. Maybe it's because we are the most recent one, and maybe we are the ones who adapted the best in the past 100,000 years or so. So we don't exactly know why we are the only ones who survived. Did we ensure that the Neanderthals were wiped out? Was there a conflict between the Homo sapiens and the Neanderthals? That is something that has been speculated, but we don't have complete evidence of that. We do have evidence of interbreeding between us and them, and same for the Denisovans and so on. So it is most likely that Homo sapiens was the most adaptable in the past quarter of a million years, and that's why we have survived. And maybe we were the most intelligent ones, and we interbred with these other species. We absorbed their best traits, their best DNA traits, and that's what we carry with us today. So that is in brief about this question. Avinash says, is dark energy negative energy? Well, dark energy is an unknown form of energy. It is not negative. It is definitely positive energy. It does produce some kind of repulsive force effect. It produces it causes, it seems to cause the accelerating expansion of the universe. So that's all we know about it. It's one of the most mysterious things that we know of in the universe. It makes up more than 80%, more than 73% of the mass energy composition of the universe, and we don't have the least idea of what it is. So it's an extremely mysterious thing. But what we know is that it is not negative energy. It is not that. It is positive energy, mass energy, whatever you call it. It's not negative energy. But that's all we can say about it as of today. It's one of the greatest mysteries in existence. Ishwar Moody says, which is a better fuel of the future according to you? Solar, electric, nuclear, or hydrogen? So solar fuel, nuclear fuel, hydrogen, they all have a, they all have good prospects. It all depends on the context. So nuclear fuel is it's very energetic. It gives you a great deal of energy output from a very little amount of fuel. So that's a good thing. And if you can use it the right way, it can maybe have almost no. It may not cause any pollution if you know how to dispose of whatever is left behind. And in the future, we may be able to use materials such as helium-3, which is found in abundance in the lunar regolith, in the soil of the moon. So that could power future fusion reactors. And fusion reactors they will be extremely fuel efficient, and there will be almost no byproducts, waste products from that. So that is a very good future fuel. So it has good prospects for the future for sure. Solar energy, if we can learn how to harness it more efficiently, is also a very good prospect for the future. Hydrogen is found in abundance in the interstellar medium. So in the future, if someday we are able to travel across interstellar distances, then that could be a very good source of fuel, especially in the context of what we discussed earlier, the Bussard Ramjet kind of engine. So so all three of them have different applications depending on what context we are in. If we are to be an earthbound species, then nuclear energy makes a lot of sense, especially if we are able to build fusion reactors. If we can use helium-3, for instance, that's a great source of energy. Solar energy is also great if we are within the solar system, especially close to the sun. And hydrogen makes sense if you're traveling interstellar distances. So all three have good future prospects depending on the context in which they are being used. Shivansh says, can you please speak about asteroid mining and resource extraction? What are the potential problems in this process? And what are all the feasible methods by which we can do it? And does it have the potential to create another benchmark in the history of wealthy people? So, in the future, I've spoken about how asteroid mining can possibly create trillionaires in the future, because there is so much mineral resources, etc., that one can extract from asteroids. Now, here is a reality check. See, the vast majority of asteroids are small, the shape of a small rock, or maybe tens of meters in diameter. That's quite small. And the amount of minerals you can extract from an asteroid that is maybe 100 meters in diameter is just a few grams. Maybe a few grams of cobalt, maybe a few grams of gold or aluminum. So, an asteroid which is about 100 meters in diameter is not that good of an investment to go all the way there and to try and extract minerals or resources from it. Now, the other thing is that the average distance between any two asteroids is about 1 million kilometers, which is more than double the distance between the Earth and the Moon. So, if you go to one asteroid and you check it out and you discover that it doesn't have too many minerals in it, it's not mineral rich, then to go to the next asteroid would be at least 1 million kilometers away. So you would need to spend that much fuel to go all the way there and then try the other asteroid and see whether it has any resources or not. So it is not an efficient process. The asteroids are they are so far away from each other, and most of them are so small that they are not a valuable investment for you to spend so much money and resources going all the way to the asteroid belt and going to one asteroid, and we don't know which asteroid contains what minerals. There is no price tag on an asteroid that this asteroid contains these many metric tons of material and these many tons of gold or cobalt or aluminum inside it. There's no way of knowing unless you actually go there and do some prospecting. And even if you find a large asteroid with a significant amount of some mineral that you need, how are you going to extract it? You cannot do extraction in space, right? Extraction is done in refineries. On Earth, you have iron refineries or other refineries of other things, of other materials or minerals. So there's an entire process that you have to create, an entire factory that you have to set up. You have to first grind the material, then put it through various chemical processing, maybe some heat treatment, and so on. It's a multi-stage process. You just can't do it in space. So it is actually extremely impractical and unfeasible to do any kind of asteroid mining with anything close to the kind of technology we have today. So it may not be possible for the next 100 years or maybe even the next 1,000 years, unless we can find ways of knowing from far away which asteroid contains how much mineral or whatever substance we are seeking. And then we may be able to target those. But as of today, it is extremely unfeasible to even think of asteroid mining. So it is not something that's going to be possible in the next century. It's not going to create trillionaires anytime soon. It is still very much in the realm of science fiction. Ashna says, what's your take on light pollution? Yeah, light pollution is something that most people are not aware of. So just 20, 30 years ago, the skies were very dark across the world. But today, if you see, most cities, most urban centers, most towns, there is so much light that you can't see anything in the sky in the night. You can see barely a handful of stars in the night. In the past, like 30 years ago, 40 years ago, you could see the entire Milky Way in the night, even in small towns, even in cities at night, because there was so little light pollution. So light pollution essentially is that we have so much light now on the surface of the planet that it goes up into the sky, and because of the kind of gases we have in the atmosphere, either smoke or pollution, or even the clouds, So all of this light is reflected in the atmosphere. The entire atmosphere glows, and because of that, it is impossible to do any astronomy or to do any stargazing or anything like that. So that is light pollution. There is so much light glow in the sky at night that you can't see any stars anymore. You can barely see a handful of stars, and that is something that is impacting a lot of things, not just stargazers and astronomers. It is impacting the circadian rhythms of people. It is impacting the circadian cycles of other species of birds, of animals, because the circadian cycle of animals and birds and insects depends on the fact that the night sky is supposed to be dark, and only for a few hours of the day you have light from the sun. So it is messing up the circadian cycles of non-human species. It is even messing up the life cycles of plants and trees. So it is going to have long-term effects, and it is something that hopefully should be combated. So what needs to be done is that our light um, sources need to become more efficient. We are wasting too much of our light, just throwing it up into the atmosphere. What we need to do is we need to ensure that all of it falls only on the ground and doesn't uh, get wasted. So it not only causes light pollution, it is also a wastage of energy. So that is the situation we are in. There is a great deal of light pollution. We can actually see the entire state of the planet from space. At night, we can see the entire planet lit up. You know, you can see the various towns and cities. You can see the whole country of India from space. It is so bright at night. So that is all light pollution, and that is an enormous wastage of energy. We need to become more energy efficient, and if we do that, we will also be able to reverse this effect of light pollution. Tanishk says, do you think that hackers will be the future soldiers of a country? They are already soldiers, hackers, because hacking is one of the major domains. The cyber domain is one of the major domains of warfare nowadays. So, using computer hacking, using cyber techniques, you can even cripple countries overnight. You can cause traffic jams, you can cause disruptions in traffic, you can uh, halt stock exchanges, you can cause electrical grids to collapse, you can cause blackouts, power outages, and whatnot. You can stop the entire communications of a country. All your phones will go dead, your internet will disappear. It can cause chaos overnight, and today many countries already do have the capability of doing this, and certain trial runs may actually be happening from time to time in various parts of the world. So yes, hackers will indeed be uh, they are indeed considered to be soldiers. For example, the Chinese army, the so-called People's Liberation Army, has a cyber division. So those are all military officers, those hackers. So yeah, it's already part of the military domain, and so are other domains as well. But yes, hackers are indeed soldiers. They can be considered to be soldiers. Avinash asks, how will the universe end? So there are a number of theories of what will happen, the long-term fate of the universe. One possibility is that the universe started in a big bang, and it will die in a big rip, which means the universe will keep on expanding forever, and eventually all sources of light, energy, heat will dissipate away, and the universe will become a cold, lifeless place, and it will just go on expanding forever, and eventually everything will just rip apart. Dark energy will increase so much that even atoms and molecules will be broken up, and that is how the universe will end. That is one theory. The other theory is that the universe will expand for some time, and then it will contract again, and you will have a big crunch. So it will be a big bang in reverse. Everything will contract into itself. One theory is that there will be a big bounce. The universe will expand for some time, then it will contract again, and according to loop quantum gravity, it will not contract into a singularity, but it will contract into a volume of space that is 10 raised to minus 99 cubic meters in volume, and it will bounce back from that again, and you will have another big bang kind of event from there. So it's kind of a cyclical model of the universe. Then, according to Roger Penrose's conformal cyclic universe theory, uh, the the eventual end of the universe will it will keep on expanding, and that will in turn be the same as a new big bang kind of event. So there are a number of theories that we have, but we the kind of data that we have is woefully insufficient. We have been around for a very small time on the universe, and we know very little about it. We understand less than 5% of the universe, so all we have is theories and hypotheses. So we have these different models of what could be the eventual long-term fate of the universe, but these are only theories. We don't know for sure. So that's where we are as of today. Manab says, do aliens live among us, and if yes, are they a threat to humanity? Well, we should at least have one question about aliens, right? It's not fun until we have one question about aliens, at least. So, do aliens live amongst us? We don't have any evidence that aliens live amongst us. We have no evidence of any other alien civilization anywhere else in the known universe. And we have no evidence that any of them live amongst us. It's always nice to imagine. It makes the world a very interesting place if there are hidden aliens living amongst us. So, it's nice to imagine that, but and many people have claimed that aliens actually exist. They are here amongst us. There are claims about this. There are claims of UFOs coming and visiting us. There are claims that crop circles are created by aliens. There are these ancient aliens theorists, whatever that is, and there are other scientists and people with reasonably good reputations who claim that aliens do exist. But where's the evidence? Evidence has to be presented. Evidence has to be unambiguous. It has to be incontrovertible evidence. When you have a lawsuit, for example, evidence has to be presented in court. Evidence that stands up to scrutiny. Somebody makes a claim that does not constitute evidence. So as of today, we don't have evidence that proves beyond any doubt that aliens exist, that UFOs exist, and that aliens live amongst us. And therefore, from the lack of evidence, one would have to say that it does not appear that there is no credible or sufficient evidence that aliens exist among us. Or so if they don't exist among us, we have no idea whether they're a threat to humanity or not. So that's the answer. We don't have any credible, unambiguous evidence that aliens exist or live amongst us. Okay, that brings me to an end of these questions. Let me take some live questions. Do you have any live questions? Ask me now. Okay, let me see. Do you guys have any questions? Harshit says Area 51 is a tourist destination of aliens. Well, that's what they say. It's become a tourist spot, People go there and there are these signboards, etc., with alien faces on them, and you go there and you take pictures with that, take selfies, and so on and so forth. Some people camp out at night outside this Area 51 beyond the boundary, and they try and do some UFO spotting. But so far, there's been no real evidence, that these UFOs exist. Amir Khan is an alien. Well, show me the proof. He does look like an alien, but we don't have proof of that. They even said Michael Jackson and some other prominent people are aliens, but well, where's the proof? It's nice, it's humorous, but well, it's only that, isn't it? It's only humor. Kapil says, what will be the source of energy once humans achieve type 3 civilization status? A Kardashev type 3 civilization. So what's a type 1 civilization? It's a civilization that is able to control all the resources of its home planet, Type 2 means you're able to control the resources of your home solar system. And type 3 means you're able to control the entire resources of your home galaxy. So I would say that if humans can achieve type 3 status, it means that we would be able to build a Dyson sphere around an entire galaxy. So the light heat output of the entire galaxy would be the source of energy of a type 3 civilization. Okay, do we have other questions? Galaxies look stationary, then why do scientists say that they rotate? I think I've answered this question before, but let me take it again. So there is something called redshift and blue shift. It's the Doppler effect when it is applied to light. So in the Doppler effect, when a train is coming towards you and it is blowing its horn or whistle, you hear a very high pitched sound, but the moment it passes you, the sound, the frequency of the sound changes. It becomes lower in pitch. So that is the Doppler effect when applied to sound waves. Now the same phenomenon is applied, it also exists in light waves. So when a light source is coming towards you, its frequencies are its wavelength is compressed, and its frequencies look its colors look bluer. So all the frequencies are shifted towards the blue end of the spectrum. That is called blue shift. And when a light source is moving away from you, its frequencies are all red shifted. So when you see a galaxy which is in the same plane as you, and when one end of the galaxy is observed, one finds that it is either red shifted or blue shifted. If one end is blue shifted, you find the other end is red shifted. Or if you find this end is red shifted or blue shifted, the other one is red shifted. So you always find that one end of the galaxy, the light, so the light that comes from it is shifted towards the blue end of the spectrum, and the other end is shifted towards the red end of the spectrum. So that tells you that one end of the galaxy is coming towards you, the other one is going away from you, and that is unmistakable evidence of galactic rotation. So that is one of the best ways of seeing for yourself that galaxies do rotate, and that's how we know that galaxies rotate. How to become a physicist and historian like you? Well, it takes many years. It takes decades. You have to study a lot, read a lot. In the case of physics, you have to start with learning mathematics. You have to learn really advanced mathematics to understand physics. So if you put in the hours and if you put in the years in learning mathematics, then physics becomes incredibly easy, because mathematics is the language of physics. And when it comes to history, well, I have learned history by reading hundreds of books and thousands of articles, research papers, etc. It takes years, it takes decades. It's not an easy thing to do. Okay, some more question. Saket says, is our country a secret superpower? Well, if it's a secret, it's a secret. We don't know about it. From what I see, from what I observe, India is not anywhere close to being a superpower. Maybe we are developing some capabilities right now, technological, scientific, etc., military capabilities, and so on. Perhaps we may be doing it in secret. It is always best to develop such capabilities in secret. Don't tell the world about it. If it is being done, I would be very happy about it. Nobody would be happier than me if we are doing that. But from what we see, from what is known in the open, we are not close to being a superpower or even a regional power. The kind of statements our foreign ministry makes, etc., is that we are aspiring to be a regional power. So that tells you where we are today. Of course, you must conceal your capabilities. You must bide your time and hide your capabilities if you are serious about being a great power. So I very much hope it is being done. But if it is a secret, we are not meant to know it. So as of today, we are not a superpower. Maybe we are trying to become a secret superpower, which would be a good thing, but I don't see any evidence of that, and maybe with good reason. Okay, some more questions. Maybe one more question. How do you remember many historical events and other information? Well, if you're curious, if you're interested, you remember things. When you go and watch a movie which you find very interesting, don't you remember everything, every last detail? So if you have the curiosity about it, you will remember things. And the more you read about history, the more connections you make inside your subconscious mind about various events that seem to be very far apart. So the more you read, the more you study, the more connections you make, the more patterns you see, and that's how you remember things. And I don't try to memorize dates. I know in which century something happened, or maybe in which decade something happened. But most likely, most usually, I don't remember the exact dates. It is pointless to try and memorize dates, because then you are distracting. You are not focusing on what's more important, which is causality, cause and effect. So what's more important is to understand why things happen and what are the forces that make things happen, historical events, right? Not what date what happened. But unfortunately, in our in education system, all we have to do is memorize dates, which is a painful thing, and it doesn't really give you any understanding of why things happen and why and what forces shape the events of the world. Okay, one more question. We are going towards geopolitics. This is supposed to be science. Is our galaxy rotating around something? Well, our galaxy is rotating around its center of mass, around the center of the galaxy. And the center of the galaxy is a supermassive black hole, which is, I think, several million solar masses in mass. So that is what it is revolving around. Is it orbiting around something? We are not very sure. We have a local supercluster, the Virgo supercluster, which is a local collection of galaxies, several hundred or maybe several thousand galaxies. So that is what it is. But we don't know for sure if this collection or cluster of galaxies is orbiting something else. We don't know for sure. Okay, one more question. I will take one final question. Somnath asks, do you think Neanderthals, who are sort of extinct now, had a role in Indian history? Is it possible they could be Vanarsena, as they looked more like apes? I don't know. See, they seem to have gone extinct as a distinct species about 20 or 30,000 years ago. That is the best evidence that we have. Now, I don't know of any evidence of Neanderthals in India, because we don't do any archaeology, we don't do anything. So even if the evidence exists somewhere in India that they may have lived in India at some point in time, we have not found it. And therefore, in the absence of any evidence of fossilized remains or other remains or artifacts of the Neanderthals, in the absence of any such evidence from India, we cannot say for sure whether they lived in India, and if they did live, until what time were they alive in India. We can't say. So, in the absence of any form of evidence about it, we cannot speculate about whether they have been part of the Vanarsena because they look like apes. We don't know. We will know only if we have some evidence. And we don't even know when the Ramayana happened, when those events happened. It's clearly several thousand years before today. Maybe the Rama Setu can give us some clues. If our government will go and do some dating activity there, then we may know when this structure was constructed. But as of today, it's too unambiguous. We have very little data, so we can't say. So unfortunately, we don't have the answer to this question. It's a good question, but we don't have an answer to it as of today. Okay, my friends, this brings us to an end of this session. Thank you so much for all your questions. Thank you very much, and I will see you in the next episode. I will see you very soon. Until then, take care. Thank you very much, and have a good day. Have a good night. Bye.